All right, guys, so welcome back from the interruption. So as I was saying, that now we have equation 1 and equation 3 has the coefficient of x to be the same, then we are working with those two equations to eliminate x. And so what we are doing here, we are taking away equation 1 from equation 3. Bear in mind, we could do it the other way around. We could take away equation 3 from equation 1. Just that in that case, we'll be working with negative values. However, it makes more sense to take away the equation with the smaller values from the equation with the larger values, all right? So now, when we subtract from both equations, so we subtract 3x from 3x, 4y from 21y, 11 from 45. Now, clearly these going to cancel because you take away 3 from 3, you get 0. And that's how we eliminate x. We get rid of the x that way. So now we are taking away 4y from 21y. And then we are going to take away 11 from 45. And so what we will get next, we will get 17y equal to 34. So now that we have y by itself without the x, we can solve now for y by simply dividing both sides by 17. So if we divide both sides by 17, so we divide this side by 17, we would have gotten rid of the 17. And if we divide this side now by 17, sorry, that's supposed to be 17. Then what we would get now, we would get y to be equal to what? 2. So now we would have solved for y. But remember, once we are solving simultaneously, we are solving for two variables. We're solving for x and y. So we're not complete until when we find the value for x. So to find the value for x now that we have y, we need to plug that value for y in one of the equations with the x, and then we solve for x. And so after we have done that, then we can conclude what the values of x and y should be. All right. So here we are now substituting for y equal to in equation 1. And remember, we're choosing one of the equations that is easiest to calculate. So we choose the equation that is easiest to calculate. So in this case, we choose to put it in equation 1 so that we have smaller values to work with in our calculation. So we would have 4 times 2, that would be equal, the 2 here would be the y. So we now have 4 times 2, we made that calculation. So we have 4 2s 8. Then now we bring the 8 across on the other side, subtract it from 11. So remember, this is when you multiply this, you get 8. And then now you bring it across and then subtract. And now we subtract 8 from 11. And so 8 from 11 will give us 3. And now you would divide both sides by 3. Now I realize that some of the steps kind of skipped. So let me just, for clarity, let me just get you to see exactly what is happening. So here when we multiply this, we get 8. Then down here, we bring the 8 across, we get 11 minus 8. And then now, we would get 3 after we minus 8 from 11. So we take this 3 now and divide both sides by 3. All right, so here we would have 3. And so We divide this by 3 too as well, and that's how we end up with this down here. So x is equal to 3 over 3. And so x would be equal to 1. And once we have the value for x and the value for y, we can conclude, hence, x is equal 1 and y is equal 2. All right, and that would be where we end our solution, in other words, that's where we would solve our problem. All right, everybody follow so far? Are you comfortable? Raise your hand if you're following and comfortable with what we're doing. What about you, Ms. Brown? I'm not seeing Miss Brown hand at all. It seems like Miss Brown is still a little bit uncertain. All right, so here now, I want you to do this one. But before you do this one, I'm going to walk you through the first part here. Now, what's the first step that we need to do when we are solving? Ms. Waysome, what's the first step?
Sir, the first step, we're going to eliminate one of the unknown. We're going to select.
So we choose which one we want to eliminate. So that's the first step. Which one you want to eliminate? You want to eliminate x or you want to eliminate y? Now, if we choose to eliminate x, what can we do to make the coefficient of x the same?
So you multiply.
Sir.
You're adding anything to this? Miss Dorothy said that we should multiply. Anybody else adding anything to what Miss Dorothy is saying?
Yes, sir. I was saying I agree with Miss Dorothy, but I wanted to find, is it possible that we could multiply the first equation by 4 and the second equation by 5, sir?
Yes, it is possible. And in fact, that's the way you do it. That's the easiest way to do it in order to make them the same. So to make the x coefficient the same, what we do, we take the coefficient above and multiply the equation below, and we take the coefficient below and multiply the equation above, right? Now, so if we do that, what it means that, what that really means is that we would be multiplying equation 1 by 4, and we would be multiplying equation 2 by 5, right? Is that clear to everyone? Now, when you do this now, you're going to get 2 new equations. You're going to get equation 3 and equation 4. And those 2 equations will have the same coefficient of x. And those are the 2 equations you're going to work with. So with that said, can you continue on and solve this problem now on your own? So I want you to try that for me now. And then whenever you're finished, you raise your hand. All right, guys, I'm going to give you about, I'll give you about 6 minutes to do this question. All right, you may begin, guys.
Stop.
Anybody making any headway with this? Hey guys, anybody? How about the two equations that you derive from multiplying equation 1 by 4 and equation 2 by 5? What are the equations you get from that? Anybody?
20x plus 12y equal to 116 and 20x plus 35y equal to 185.
All right, so if you're eliminating x, then you would get these two equations. Did everybody get that? Okay. Was that what you got, Miss Green? I mean, Miss Waysome?
Yes, sir.
Okay. All right, raise your hand when you're through solving for x for me. All right, Miss Green, what is it that you got for your answer?
I got y equal 3 and x equal 4.
Okay. Anybody else got that answer? Let me see your hand if you got the same answer as Miss Green. All right, Miss Waysome got the same answer. How about you, Miss Brown?
Sorry again. No, y equals 3. I'm doing the other part.
Okay. Miss Cabrera, are you getting along well, Miss Cabrera?
I'm catching.
Yeah, I realized that you were a little late. All right, so for your y value, y would be equal to 3. Was that what you got, Miss Green?
Yes, sir.
Okay. Miss Brown, that's what you got? Are you with me, Miss Brown? Are you working the problem? All right, so if we substitute for y equals 3, what we'll do is choose one of the easiest equations to substitute it in. Here we are substituting y equals 3 into equation 1. And when we plug that in, we get 5x plus 3 times 3 equals to 29. So 5x equal to 29 minus 9. So 5x would be equal to 20 divided by 5. And x would be equal to 4. And so our solution would be y equals 3 and x equal to 4. All right, guys. All right, I'm going to move on to the next question. Raise your hand if everybody is okay with this one, please. All right. Okay. All right, here is another one. I would like for you now to try this one without my help. Raise your hand when you're finished so that I can see who is finished. All right, guys. All right, guys, time is running out a little quick for us. All right, so let me see if I could just assist you with this one. Which of the unknown you decided to eliminate for this one? Which one of them is easiest to make the coefficient the same? Well,
Sir?
yes, go ahead.
All right, so what I did, sir, was multiply 7 by 4 and 4 by 7, giving it 28 both ways.
All right, so you would have chosen to eliminate. All right, but I thought as much that some of you would have opted to do that. But what I want to show you as well, that sometimes you need to consider eliminating y.
Yes,
Because
sir.
you notice here, this term here can be easily turned into a 4 if you multiply this equation by 2, right? And so this would now give you 2 4s, 8x, and 2 times minus 2, which is minus 4y. And then you would have 2 times 2 here, and you will get 4. And this would be equation 3. And if you are now working with equation 1 and 3, then this would be 7x so we would have 7x, and then now we would have plus 4y, and then now we would have 41 here. Now, in this case, because y is easiest to eliminate and the signs of the y are different, then it means that we could just add equation 1 with equation 3. If we add these two equations, then we have 7 plus 8 will give you 15x. And when we add the y's, a positive plus a negative of the same value will cancel. And then now we add 41 with 4, we would just simply get 45. So we have 45 here. And next we could just divide both sides by 15. Divide this side by 15. And 15 cancel on the left. So we are left with x is equal to 15 into itself 1, 15 into 45 goes 3. So x is equal to 3. And now we could just plug back x equal to 3 into one of these. Maybe equation 2 is a better one. So in equation 2, for x equal to 3, this is what we would get. We would have, this implies we would have 4 times 3 minus 2 times y is equal to 2. So here we would have 4 3s 12 minus 2y equal to 2. Now we'll bring the 12 on the other side. And so minus 2y would be equal to 2 minus 12. And so when we take away 12 from 2, we get negative 10. And we divide both sides by negative 2. We see that y would be equal to positive 5. All right, so that would hence be our solution, x equal to 3, and so hence x equal to 3 and y equal to 5. All right, so that would be our solution. All right, guys. All right, so I'm just going to flip through. So eliminating y, multiplying equation 2 by 2, we get that. And then now adding equation 1 and 3, we get that. Divide both sides by 15, we get x equal to 3. Substituting for x equal 3 in 1, we get 7 times 3 plus 4. So we would have 41 minus 21. So y is equal to 20 divided by 4, y equal to 5. So you see, we would have gotten that solution. All right, guys, now we're just about out of time, so I'm going to stop here. Before you go, I would like to make a quick announcement.